In every assembly language program, branches are taken to transfer execution from one location to another. These are often conditional branches. A conditional branch is one that is taken or not taken after a test of the setting of the flags. They have the same form. All the instructions begin with the letter J, which is short for jump. The only operand they have is the label to which the branch is to be taken. The most basic branch instruction is the unconditional jump, but there are a number of branch instructions based on the setting of the condition codes. Most instructions set one or more of the condition codes. An instruction designed to do nothing but set the condition codes is the compare instruction. It can be the comparison of the contents of registers with memory locations, or with other registers, or with immediate values. To do this, the value of B is subtracted from A, and the condition codes are set according to the results. But the results are discarded. The only thing that happens is the setting of the flags. There are lots of jump instructions that are controlled by the flags. These are the basic numeric comparison branch instructions. On the left is the assembly language mnemonic. In the center is what the mnemonic stands for, and on the right is the flag that makes them branch. For example, the first one is JE, jump if equal, and it will branch if the 0 flag is set to 1, which indicates that the compare subtraction resulted in 0. The second one is JNE, jump if not equal, which will branch if the 0 flag is not set to 1. And look at the next two instructions. They're exactly the same. They actually assemble into the same opcodes. Which one you use depends on what makes sense to you in your program. Now, there are several instructions that will clear or set this flag, and these same jump instructions can be used for them all. There is nothing magic about the names other than they tell you which flags are being tested. There are lots of jump instructions. Here are some that test single flags: the carry flag, the sign flag, and the overflow flag. Now, you saw earlier there were tests for numbers being greater than or less than. Those tests were for operations with signed numbers. The term for unsigned numbers are above and below. You will notice that the difference is only in which flags are tested after the comparisons are made. And there is the testing of the parity flag. You can use JP and JNP to test whether the parity flag is set. Or you can use JPE and JPO to jump on either even or odd parity. Of course, you'll need to be certain that the operations right before the jump sets the parity flag. All the conditional jumps depend on the results of the instructions just before them. That is, all except two. These two conditional branches test the contents of the CX register or the ECX register and branch if the value is 0. This is a special instruction for looping, which uses the CX register or the ECX register as a counter. It can be used at the top of a loop to prevent entry into the loop if the count is already 0. These instructions are used at the bottom of a loop. They decrement the counter, and if it is 0, just drop through. If the counter becomes non-zero, they jump to the label specified as an argument, presumably the top of the loop. You will notice that some of the instructions also test the 0 flag. They will drop through only if the flag is set properly and the count goes to 0. These are some other jump instructions: call and return. These will be explained later in the lesson on functions and passing arguments. One thing I need to mention is short jumps and what you can do about it. Most of the jumps are limited to a very short distance because they only allow 1 or 2 bytes to hold the offset of the target address, so you may find yourself with an error message coming out of the assembler telling you that you can't make a certain jump because it's simply too far to go. That's a limit of the instruction set, but you can overcome it easily. Say you've got a jump on 0 instruction that gives you the error that the label is too far away. You can write the same thing this way. Change the test to branch on not 0 and make it to a local spot just past the next instruction. And for the next instruction, you can use the unconditional jump command, which doesn't have that distance limit, so it can branch anywhere.